Key database. Database structure that allows you to securely store keys together with descriptions and other attributes. Key database. The main reason for using key databases is the use of large random keys such as private keys. By storing these keys in a database along with names and descriptions of each key, you remove the need to remember them. The user simply has to select the appropriate key by its name and description. As information technology continues to evolve and offer more ecurity measures, consumers will embrace key database products. There are many different ways to implement encrypted key databases. Only one will be discussed because of its dexterity. Although it isn't very convenient for large databases, it is very adequate to manage a few dozen keys. The biggest concern is the key database's encryption key. It should be lengthy but easy to remember. It is recommended to use phrases for the simple fact that anyone can remember a 4-word phrase which usually contains 15 to 20 letters. The phrase should not be used as the key intact. It should be reduced to offer as much entropy as can be afforded. 128 bits is a more generous key size that provides abundant security for this implementation of a key database. The next issue is known plain text. If an attacker knows most of the names and description of the keys, he can employ a known plain text attack. This sort of attack attempts to discern the key from bits that are known to be in the encrypted data. These attacks require massive amounts of known plain text, but no chances can be taken. The best way to stop known plain text from compromising the keys in the database is to encrypt all predictable information with a separate key. The key that encrypts the names and descriptions should either be a key dedicated to this task and contained in the database with the other keys, or a hash function of all keys in the database. Either solution keeps the keys from being compromised by an attacker who managed to decipher the names and descriptions. The key database's structure should contain the least amount of predictable bits as possible. Predictable data that cannot compromise the keys should be at the beginning of the database and should not be encrypted. With this in mind, the size of the keys should be stored in that manner. The next block of information should be the sizes of the names and descriptions of each key. These sizes do not reveal any security-critical data. Next in the database should be the keys. They should obviously be encrypted. There should be no markers in between keys. They are useless because their sizes are known, and you can easily calculate each key's placement. If you choose to assign a key to encrypt the names and descriptions, it should be placed after all other keys and encrypted in the same manner as all other keys. After the keys should be the names and descriptions, and like the keys the names and descriptions do not require markers. This concludes this basic architecture for a properly implemented key database. There are many more security concerns that need to be accounted for on behalf of the software itself. Cleaning up of memory after completion is necessary in all security-related software. Security is a process, not a recipe. C. Copyright Dr. Monkey 2000.